Hi everyone, in this video I will explain how I have built this custom lighting setup for my mother's Christmas nativity scene. I will walk you through the hardware and software, explaining how everything comes together step by step. This project is excellent for beginners. It is straightforward, fun and perfect way to get hands-on experience with Arduino and NeoPixel LEDs. Well, my mother asked me to add some lights to the nativity scene. The nativity scene consists of the typical porcelain figurines, the baby Jesus, Mary, Joseph, a sheep hand, 3 kings, an angel, an ox and a sheep. The stable is simple and made of wood, moss and bark. I had the idea to install multiple color lights and make them fade seamlessly and slowly from one color to another. Let's go and start with the hardware setup first. For the microcontroller I used an Arduino Nano compatible board. This board is powered via a mini USB connector. As the next step we need to connect the NeoPixels, which are our LEDs. For this I'm using a 3-wire cable. The first wire is connected to 5 volts to provide power to the NeoPixels. The second wire is for the control data, which sets the colors of the pixels. And finally, we also need a ground wire. All 3 wires are connected to the Arduino board, allowing us to control all the NeoPixels while supplying them with power. The NeoPixels used here are the SK6812, primarily because of the additional white LED. Each NeoPixel has a 3-pin input and an output port, and they are connected in series this way. 6 NeoPixels are installed in total, 1 at the rear side and 5 in the front. Alright, let's go quickly through the code. So first of all I used the Adafruit NanoPixel library. I have defined the port for the onboard LED, but most importantly we have to define the pin which is the output for the LED strip. So this is a data pin, which I have, in my case it's at the D3 port. Then we need the total number of pixels. In my case I have 6 pixels in total, so I have 6 lights in total. And then we can already initialize the objects for the Adafruit NanoPixel. The first parameter that we have need for the initialization is the number of pixels that we have defined above, the port that we are using, and then in my case I'm using the SK6812 LED type, so I need 4 channels, and for me the 800 kHz as data frequency worked very well. If you're using another LED type here, so you have to choose the parameters accordingly. Next we have the common Arduino setup routine. In this routine I'm initializing the onboard LED as an output. Then we have to initialize the LED strip objects that we have here with begin. Then I recommend to call this show routine. Can ensure with this that you turn off all lights before you start your system. And then I have defined the setup scenes routine next, which is below. We will come to it soon. In the structure I have defined all 4 colors, red, green, blue and white. I'm using here already this here in my scene definition. What is a scene? I have 6 lights in total, and a scene defines which color has each light. And we are fading from one scene to another seamlessly. I have 10 scenes in total, and we are fading from the first to the second, from the second to the third, and in between we have amount of time that we are waiting until we fade to the next scene. And once we have reached the last scene, in this case number 10, so we'll start over again and fade to the first one seamlessly. So to do this I have this progress, and it says basically that we are starting fading if it's 0, and 1 we have finished fading to the end of the next scene. OS is a scene that we are fading out, and CS is a scene that we are fading into. Then I have to define my lights, and the backside I have a light to illuminate the wall at the back. Then I have a left and right spot inside, above the ladder and under the ladder light, illumination spotlight, which is integrated into the floor to illuminate the Gloria inscription and the faces. So then I have the setup scenes routine that I have mentioned, and what we are doing here, we basically define for each scene. This is the first scene, the second, the third, the colors. So we will fade from this color. It's the left spot is white at the beginning, the side high spot is blue, and we are fading to these colors here, or we are using as spotlights basically, and we define each scene we define here step by step until we reach scene 10. You could define more scenes here if you want, right? So then we have this routine load next scene, which is changing from one scene to another. What it does is changing the current scene to the scene that we are fading to. It increasing the index, and then when we reach the end of the last scene, I'm using the modulo parameter here. You can also use if it's larger than scene numbers and set it to 0. Then we are updating for the current scene the pointer from our array of scenes here to the next one, which we have incremented here. Right, then we have the main loop. It's also routine from Arduino, and I have this progress that I have mentioned above, and this progress defined at which point we are here in the fading process, and here's the step which speed that I'm fading basically. Once we have reached the number 1.0, so we start over again and set it 0 and load the next scene. And I have this fixed delay here. I commented it out, and I'm not using this because I need to hurry up here. So I have a fixed, and it works for me very fine. Yeah, you can change it if you like. I have 10 seconds, a fixed number in between the scenes. So here's the actual fading routine. So we are fading from one color to another. Red one, green one, blue one, white. This is the colors that we are fading from. And red 2, green 2, blue. This is the color from the pixels that we are fading to. And we are calculating depending on the progress. So yeah, it's 0.5. So it's like calculating the average of red 1 and red 2. And this is exactly what the routine does, right? It's fading from one color to another. So then this object wants us, of course, to update and tell it what color changes we have. We do it for every pixel. We update the state until we have reached the end of the fading. That's it. That's the whole code, and that's all we need. And you can make changes. You can improve this code if you like. All right, that's about the code. You should have everything you need to start your own illumination project. Let me know in the comments about your illumination ideas and what you would suggest doing differently. And you are welcome to subscribe for further updates.